All right, this is part 2 of section 1.5 with the systems of equations by graphing. Okay, yesterday we spent the whole day talking about slope-intercept form, right? So as a quick refresher, what does this B stand for?
The y.
That's the y-intercept, right? So that's our starting point, y-intercept. And then what helps us get the rest of the points? The m, right? What does this m stand for? The slope. Okay, so we practiced graphing lines yesterday. Today we're going to get into graphing absolute value functions and quadratic functions. Okay, so first thing I want you to write down on your note sheet somewhere. So anywhere on your notes, we're going to talk about absolute value functions. Now, as a refresher, these are the GL bar functions. Okay, does anyone remember, if I could draw a quick sketch, what these look like? What do the absolute value ones look like?
V.
It is a V, yep. Absolute value functions look like a V. Let's pretend I put a negative sign in front of there. What happens to the function? It gets flipped upside down, right? So remember that there. I'm just going to give us a specific example here. Everything I write down, I want you to write down also. Okay, so I'm going to give us a specific example. I'm going to do y equals the absolute value of x plus 2 minus 3. Okay. You might have equations that look like this. And what we want to do is this gives us our starting point. Okay, so normally with the lines, right, we had the b or the y-intercept giving us our starting point. For these, we need to know where this vertex point is happening. Yeah, so remember these two values right here tell us what happens to the vertex. So this has to do with the x value. Do we think normal or think opposite? Yep, for the x values we have to think opposite. So plus 2, you would think right 2, but we have to go left 2. So left 2. And then this outside the GL bars or outside the absolute value is dealing with the y's. So minus 3, do we think normal or opposite? Normal. So minus 3 is down 3. Sorry, I should say left 2. So this right here gives us our starting point. So our starting point left 2, that would be negative 2, down 3, negative 3. Okay. So right here, this is our starting point. Okay. Last thing we have to talk about is to get all the other points to make our V. Okay, it's actually pretty simple. From that vertex, if I draw a little makeshift graph over here, here's my vertex at negative 2, negative 3. What we do to get all the other points is we just go up 1, over 1. Over and over and over again. So up 1 over 1. How do you think I get the other side? How do I get this side of the V? We're going to go up 1 over 1 again. Yep, so it just mirrors on the other side, up 1 over 1. Okay, and then that creates your V. So biggest thing with absolute value functions is we use this up here to get our starting point. Okay, so let's get into an actual example here. You do not have to write this down. But right here, I have the absolute value of x minus 4 equals 1/2 x plus 1. Right now, does this look super confusing? Does it look like a mess? Okay, what I want you to realize is we are seeing two different equations. We have two different equations here. So what we're going to do is we are going to rewrite these equations as their own. Okay, so instead of writing them together, we are going to write them separately. So this is going to turn into, this one here is going to turn to y equals the absolute value of x minus 4. This one right here, I'm going to do the same thing, and I'm going to write that as y equals 1/2 x plus 1. All I did was I just split them up into two different equations. Okay. So let's talk about what happens here. What is this minus 4 telling us about the absolute value function? Think opposite. Yep, we have to go right 4. Is anything happening with the y value? No. So notice in the graph over here, they went right 4. That's where they started their vertex. How did they get all the other points for the absolute values? How did they get all of their other points to make the V? Yeah, up 1 over 1. Yep, up 1 over 1 in both directions. Remember, we graph until we can't anymore. So that gave us our absolute value function. Now we need to figure out what this one is telling us. What's my starting point for this one? For this equation right here.
1.
Right, the y-intercept or our b is 1, so we start up at 1 on our graph. And then how do we get all of the other points?
1.
Yeah, up 1 over 2. That is how they got this graph here. How many times did it intersect? How many times did the two graphs intersect? Twice. We have one here, and we have one here. How do we write our answers to these graphs? Can I just circle the ordered pairs?
Oh, no, you have to use them as you put in the you know what I'm talking about.
We want to write them as ordered pairs, right? So this first one is going to be 2, 2. This second one is going to be 10, 6. Okay, so really we're looking for the same idea. We're just graphing different types of graphs today. Okay, so go ahead and draw yourself a graph on your graph paper, fairly large like you did yesterday. Okay, and then we're going to do this example together. On this example, it's written together, right? What do we want to do first? Instead of leaving them together, what do we want to do? Split it up. Yep, so what happens is I'm going to take this equation and I'm going to write it as y equals the negative absolute value of x minus 2. Okay, what I write down, you write down somewhere on your notes or on your graph paper. And then the second one, we do the same thing for the right side. I'm going to write it separate as y equals negative 1/2 x minus 2. So again, we graph these as separate graphs. What do you notice about the first one here?
The y doesn't have
Nothing's happening with the y. Okay, what's happening with the x?
it's going left. No, right.
Yep, think opposite. This one's going right to. Okay, so I'm going to go on my graph over here. It's going to be my blue line. I'm going to go right to start my starting point. What else does it tell you? What is this? Oh, what does this say? So it's going to end up being flipped. So instead of going up 1 over 1, we're going to go down 1 over 1. Okay, so go ahead and make your whole graph. Go as far until you can't anymore. Okay, fill your whole graph. How do I know it's supposed to look like a V? Right, and it's the absolute value function, right? The absolute value bars, I know this is supposed to look like a V. Now we're going to graph line 2. What is this graph supposed to look like? What's my red graph supposed to look like? It's going to be a normal line, right? Where do I get my starting point from? Yep, so starting point is negative 2. Remember, that's on the y-axis. So I'm going to go to negative 2. Even though they intersect there, am I done? No. Okay, how do I get all of my other points? Yep, use the slope. Now notice it's a negative slope, so what is my line going to look like? It's going to be going down, so make sure your line goes down. So I'm going to go down 1 over 2. And then go until you can't anymore in both directions. There we have both of our lines. How many places do they intersect?
1.
I agree with this one. Do they intersect elsewhere?
Yeah.
Right here, right? What's the coordinate for this one? 0, negative 2. What do you notice about the other one? It's not very nice. So remember, if it's not nice, I'm not going to make you write that order pair. Most of the examples that you see will end up being nice. Okay? All right, last type of graph we're going to talk about for this section is quadratic functions. Okay, so go ahead and start this section of notes on some piece of paper or your note sheet. Okay, quadratic functions. Okay, quadratic functions, remember these are the x squared ones. What do these graphs look like? The x squared ones. We talked about lines. We talked about v's. These are the u's. Okay, the quadratic functions are the parabolas. Same thing. What happens if I put a negative sign in front? It flips it upside down. Okay, but the u shapes are our parabola shapes. With the quadratic functions, okay, we might see them like the absolute value functions where we don't write this, where we have it written like this, and then we can say, okay, we're going right 2 or we're going up 3. Yeah, you might see it like that. Most of the quadratic functions you're going to see are going to look like this, though. Y equals x squared plus 6x plus 6. Write that down. Okay, these are the ones you're going to see most because their graphs are a little bit different. Okay, so, again, the most important part of our parabola that we need in order to graph is that vertex point. Okay, we need to know what that vertex point is. Okay, this is going to be called finding the vertex. Okay, so go ahead, label finding the vertex. Also known as the starting point. Okay, there's an equation we're going to use. That equation is called x equals negative b over 2a. Okay, write that down. Negative b over 2a. What this means, where do you guys think we get a and b from? It is the equation, okay? What number is technically in front of the x squared? 1. That's our a value. What do you think b is? It's the next coefficient, and then c we won't use, but this number on the outside is c. Okay, so it goes in the order of a, b, c, and it's just talking about the coefficients, or the number in front of the variable. Okay, so let's plug in what we know. What is b? 6, so we get negative 6 over 2 times what's a? 1. So we get negative 6 over 2. What's negative 6 divided by 2? Negative 3. Okay, so our vertex, right now, we know our x value equals negative 3. What am I missing? We're missing the y. Does anything on our screen right now or on your paper tell us what y equals?
No.
6, because of C.
Okay, I like how you guessed 6, but do you agree y equals this whole thing?
Yeah.
Yes. Okay, y equals that whole thing. So what we need to do is we need to take the x value that we got and we're going to plug it in to each x value there. Okay, so let's go ahead and do that. We get y equals negative 3 squared plus 6 times negative 3 plus 6. I took that x value. Okay, we just plugged in that x value to all of the x's in our function. Okay, so what is negative 3 squared? 9. 6 times negative 3 is negative 18 plus 6.
Negative 21.
Be careful with positives and negatives here. If we, Logan, let me ask you this. Did you just type this in point blank in your calculator? Did you put parentheses around this?
Not on that one.
Yep, make sure you put parentheses around that. You should get x equals negative 3 also. Or sorry, y equals negative 3. So our starting point is negative 3, negative 3. You do not have to graph this, but I want to show you what happens on the graph. Okay, so you can just follow along for right now. If I have my starting point at negative 3, that is here. To get all of our other points on the graph, we're going to use something called the step pattern. Okay, this is the last part of notes we're going to take today. It's called the step pattern. Okay, what that step pattern is, and it follows the odd number cycle. So it goes 1, 3, 5, 7. Usually you're not going to go above 7. Okay, but if you did, what would your next step be? 9. Yep. So what happens here? Every time you are going to go over 1. Okay, the step tells you how much you're going up. So the first one we're going to go over 1, up 1. So we've used step 1. Now from where we're at, we're going to go over 1, up 3 on both sides. We're done with the second step. Now I'm going to go over 1, up 5. And we're done with the third step. Okay, again, and then you go until you can't go anymore. here is your parabola.
That's cool.
Okay, so biggest thing with this one is you have to do this process to get your starting point. Okay, but then you can use the step pattern to get all of your other points. Okay? All right, we're going to do a couple more examples together. Let's look at this one first. So go ahead and draw yourself a graph on your graph paper. And we're going to use this equation here. Instead of the inequality, we're just going to focus on equals 0. All right. On this one, remember, we have that equal sign. What do I want to do with both of these? Do I want to look at them together or look at them separate? Look at them separate. So we're going to turn that first one into y equals x squared plus 6x plus 5. What do I turn this into? Y equals, what's the other equation? 0. Yep, it is kind of weird since it's just 0, but that is still an equation, y equals 0. Okay, so we split it up. Now we can look at each graph separately. So again, let's look at this first one. What is my blue graph there? What is that going to end up looking like? What type of function is it? Yeah, it's the quadratic functions or the parabola. Okay, so remember, what do we have to do in order to find our starting point? Yeah, we need to know what A, B, and C are, right? What's technically here? 1, so we know that's A. 6 is B. 5 is C. So we're going to use the x equals negative B over 2A. What is my B value? 6. So we have negative 6 divided by 2 times 1. What's negative 6 divided by 2? Negative 3. So right now we have negative 3 as our x value. What am I missing? For the vertex, what am I missing? I have the x value. I'm missing the y. How do we find what the y value is? Yep, plug negative 3 into all the x's. So this turns into negative 3 squared plus 6 times negative 3 plus 5. If we evaluate that, we get 9 minus 18 plus 5, which is negative 4. So for our starting point, we get negative 3, negative 4. What do I do with that point? Graph it. Yep, go graph it at negative 3, negative 4. So we start here. How do I get all of the other points of the quadratic function, or the u? Step pattern. Yep, so I always have students rewrite what your step pattern is. What is our step pattern? Yeah, 1, 3, 5, 7. How many do we go over every time?
7.
Careful. How many are we going to go over every time? We're going to go over 1 every time and then continue using the step. So we're going to go over 1 up. What's our first step? Over 1 up 1. Now I'm going to go over 1 up 3. Done with the second. Over 1 up. What's my third step? 5. Okay, and then create your picture. So I'm done with our first function. Okay. Now we need to graph the second one. How do I graph y equals 0? It's at 0, right? Y equals 0. Here's where that point is. Now yesterday, remember, we talked about horizontal and vertical lines. Now, y equals 0, that is the only y value I want to touch. So if I go vertical, is that the only y value I'm touching? No, I'm touching every one. Okay, so we want to go horizontal across the x-axis. Okay, touching that y equals 0. Okay. Now that we have both graphed, we can see where we cross. How many intersections do we have? 2. We got 2 there. We need to write them as intercepts. Or, sorry, as ordered pairs. So what is one of them? What's this one here? Negative 1, 0. Good. What's this one here? Negative 5, 0. So again, the whole point was to find their solutions or where they intersect from. Okay. Here is our system of equations we're talking about. Okay, what is the first thing we want to do since it's written together? What do we want to do with this?
Get them separately.
Write them separately, right? So this turns into y equals x squared minus 2. Our other one is y equals 1/2 x plus 2. So let's look at our first graph here. What is the overall shape going to look like? What kind of function is that?
A U.
It's going to be a U. However, do we have A, B, and C?
No.
No. Okay, so you should like this because it makes it a little easier. What is this minus 2 telling us?
It's -2 and the y -2.
Right, it's talking about the y value, so what's happening?
Down.
We're going to go down 2. Okay, that's all that's happening, so I can start graphing down 2. How do I find all of my other points for the quadratic functions? What'd you say?
1, 1.
What do you mean 1, 1?
Like, is it 1 for the x and 2 for anything?
Oh, you're treating it as a slope. We don't want to do that. Remember, since it says squared, that's the quadratic u's. How do I make my U shape?
Oh, just like that.
The step pattern, yep. Step pattern. What is the step pattern?
1, 3, 5, 7.
1, 3, 5, and 7. So let's review the step pattern. I go over 1, up 1. That's my first step, both sides. Over 1, up 3 is my second step. Good. Over 1, up 5 is my next step. And then go ahead, draw your picture. Okay. Now we're moving on to our second line, or our second graph. What is this graph going to look like?
It's going to be a straight line.
It's going to be a straight line, okay? Where do I get my starting point from?
Y.
Yep. So our starting point is 2. So I'm going to go up 2 from the origin. How do I get all of my other points? Using the slope, right? Is it positive or negative? Positive, so we're going to be going up. So I'm going to go up 1 over 2. And then go until you can't graph anymore. How many intersections do we have? How many times do they cross? 2. What do you notice about those intersections? They're not good. They're not nice, right? What did I tell you if they're not good? You don't have to do anything. I just want you to circle where they're at. Okay? Like I said, on IXL and on your homework assignment tomorrow, they're all going to come out nice. Okay?